What if the impossible wasn't so impossible after all? Imagine a future where traversing light years is as simple as a short trip. Today we're diving into the groundbreaking science that just might make warp drive a reality, challenging everything you thought you knew about space travel and the speed of light. Hello and welcome. I'm glad you're joining us today on this voyage beyond the stars. Imagine a universe where distances between galaxies shrink, where the boundless reaches of space fold upon themselves, and we travel faster than light. That, dear viewer, is the dream of warp drive. In this cinematic journey, we unravel the science behind warp drive possibilities, the physics that challenges our understanding, and the tantalizing hope for one day bending space-time itself. From Einstein's theory of relativity, we know nothing with mass can reach or exceed the speed of light in normal space. But what if we don't travel through space in the usual sense? What if we reshape space itself? This is the core of warp drive thinking. Compress space ahead of a ship, expand it behind, creating a warp bubble that carries the vessel across cosmic distances while the ship remains locally stationary in its bubble. This idea may sound like magic, but it finds grounding in solutions to Einstein's field equations, exotic solutions known as the Alcubierre metric. In 1994, physicist Miguel Alcubierre proposed a model in which space-time itself is deformed to allow a region of flat space to ride a wave of expansion and contraction. The ship resides in a flat region, protected from extreme tidal forces. The bubble is propelled by expansion behind it and contraction ahead of it. In principle, this bubble carries the ship at arbitrarily high effective speeds without locally breaking the speed of light barrier. But there's a catch. It demands negative energy or exotic matter, something classical physics does not admit. Negative energy sounds like science fiction, yet quantum field theory hints at its possibility in phenomena like the Casimir effect, where vacuum fluctuations between two plates produce a negative energy density. But generating and sustaining negative energy at the scales needed for warp is far beyond current technology. The energy requirements calculated for a warp bubble, initially equivalent to the mass energy of a planet or more, are astronomical. Scientists have since refined and reduced those estimates by clever engineering of the warp bubble geometry, but even then they remain orders of magnitude beyond our capabilities. Another challenge: stability and causality. Warp bubbles as originally conceived might suffer from instabilities, collisions with interstellar particles, and causality paradoxes. Some researchers explore quantum inequalities and constraints that might limit the negative energy or demand new physics. Others probe whether a ring of exotic matter or fields might stabilize the bubble. The field remains speculative, but it is actively researched in theoretical physics. More recently, ideas like the Natário warp drive refine the geometry so no expansion or contraction occurs within the bubble walls, and newer papers examine energy distributions that might be less extreme. Some even wonder whether advanced civilizations could harness vacuum energy or tap quantum vacuum fluctuations in ways we cannot yet imagine. The boundary between speculative engineering and future physics is thin. If warp drives become possible, they would revolutionize exploration. A journey that takes tens of thousands of years under conventional propulsion could shrink to years or even months. Colonies across distant star systems would become feasible. But before that, we must master quantum gravity, understand exotic matter, and solve fundamental consistency issues. Despite the immense challenges, the promise is profound. In a cosmos so vast, warp drive offers hope that intellect and ingenuity might someday overcome spatial tyranny. Even if we never build a working warp engine, the theoretical pursuit enriches our understanding of general relativity, exotic states of matter, and the deep structure of space-time. So as we gaze upward at the stars, let us also look inward to our equations, our quantum fields, our boldest dreams. The warp drive may remain science fiction for now, but its study stretches human imagination and frames our journey to one day become a truly interstellar species. Thank you for watching this exploration of warp drive science. If you found this illuminating, please like, share, and subscribe. We look forward to journeying with you through the frontiers of knowledge on Infinite Expanse Docs. Until next time, keep dreaming beyond the stars, and may our curiosity always drive us forward.